Hey guys, we are going to go over the equation of tangent lines DeltaMath assignment, and I'm going to do a couple of examples from each of these sections. Alright, let's start off with slope of tangent lines. So for this function, find the slope of the tangent line at x equals -7. Now remember, slope of the tangent line always means your derivative, right? Your instantaneous rate of change. And so if I'm finding the slope of the tangent line, really what I'm finding is f prime of x, and then I'm going to plug in 7. Oops, -7. That's all it means. So let's do it. So f prime of x would be, I think, just 2x, and then 2 times -7 could be a nice -14. And so, oh goodness. Oh, they just had to go extra crazy with it. This must be with the definition. Yikes, we're going to use our shortcut rules. But just a reminder that this would be m if you were writing the equation for your tangent line, right? All right, let's try again. So for this one, we do the same thing where it gives you an equation and it wants you to find the slope of the tangent line at 7. So derivative of x squared minus 3 is just, in fact, 2x. Plug in 7, 2 times 7, positive 14. These ones are easy, especially since we're skipping the definition of the derivative here. All right, and then might as well do the last one since it's not going to take that long. So my function is x squared minus 10, so the derivative of x squared minus 10 is 2x, and I'm finding the slope of the tangent line at -3, so I'm plugging in -3, 2 times -3, -6. Easy. Cool. All right, well, those ones are easy. Let's go back and do some more, some equation of the tangent lines now. All right, so now what they want us to do is they want us to find the equation of the tangent line at particular values, right? And so typically what I do is if I'm finding my equation of the tangent line, you'll see me do a setup that looks kind of like this. So automatically, if I see the words like find the equation of the tangent line, or use the equation of the tangent line, or find the equation of the line tangent to the graph, I automatically write this first. Y minus y1 equals mx minus x1. And then I have this nice point slope form for me. I know what my x1 will be. I can figure out what my y1 will be, and then my m, remember, is just my derivative at a particular value, okay? So then that means my x value, x1 would be 3, and then how do I find y1? Well, if I have x and I want to find y, I'm plugging x into my original function. So f of 3, which would be 3 squared is 9, 9 minus 11 is -2. And then for my derivative, I'm plugging 3 into, or excuse me, for my slope of the tangent line, I'm plugging 3 into my derivative. So let's see, f prime of x would be the derivative of this function. So that would be 2x. And then I'm plugging in 3, so then I get 6. So then my equation of my tangent line would be when I fill in everything, right? Because I have all of my pieces, y1, m, and x. Okay, so let's do it. Y minus y1, so it would actually be a positive 2, right? Y minus a -2 equals m is 6, and then x minus x1 is 3. I don't know if it'll actually accept my answer in this form or if it wants me to put it in slope-intercept form, so we'll find out in a second. Nope, it's good with it. So your point, here's your slope, equation of the tangent line. Boom. All right, let's try another one. There you go. All right, so we're finding the equation of our tangent line, x equals -6. So that means that that's my x value. To find my y value, I'm just plugging in -6 into my original function. So -6 squared is 36. 36 plus 3 is 39. And then f prime of -6 will give me my slope, or my m. So if I do f prime of x first, I'll get 2x. And then I plug in -6, I would get to -12. And so then my equation of the tangent line would be y minus y1 equals m x minus x1. So it'll end up being x plus 6, I think. And there we go. Boom. All right, so that's the equation of the tangent line. Let's go ahead and now we're going to use our equation of the tangent line to do some linear approximation. So this is going to kind of just tweak a little bit how we see our equation of the tangent line. And so for this problem, we have let f be a differentiable function. Differentiable means you can take the derivative of it, such that f of negative 5 equals 4, f prime of negative 5 equals 8. And then what is an approximation for f of negative 5.1 found by using the line tangent to the graph? So automatically when I see that, I write the line tangent to the graph. Y minus y1 equals mx minus x1. Of f at x equals negative 5. Now this one's a little bit weirder because I don't actually have any an equation to work with, and I don't have any y's or m's or anything listed for me. So we're going to rewrite this in another way, which it's just a different form of the problem, but it will make it easier to identify like the pieces from this description that fit into pieces of this equation. So for example, we in pre-calculus and onwards basically only use f of x to represent y, so we're going to do that here as well. So f of x is your function, and then if I had actually plugged in a value to my function and gotten out my y value, essentially, I'm trying to figure out a different way to phrase that, but like let's say I'd picked some, oh here we go. So if on a graph, right, if I plug in some value a into my function, then the answer would be f of a, right? That this is just your x1, and this one was just going to end up being your y1. It's just written in different ways, right? So in this scenario, y minus y1 would be f of x minus f of a equals, and then we'll fill in our x part as well, right? That's just an a over there. And then this middle part, right? If this is my x value and this is my y value, how do you find the slope of your tangent line? Well, it's your derivative at that point as well, okay? So this is just a different form of the equation of the tangent line, but it's more helpful when we are presented with problems that only have f of things in them. So for example, when we're writing the equation of this tangent line, your f of x is always just going to be f of x because it's not at a particular value, minus f of a. So that means when I actually plug in, oh, it might be helpful. Hold on a second. Let's try this again. X equals negative 5 is what they're telling us. So what they're basically saying is that your a value over here is negative 5, so this will end up being x plus 5. But then that means that your f of a is going to be when I plug negative 5 into my original function, just like normal. So f of a would be 4. And then f of x is still f of x, right? Same thing. X was x, y was y, that's fine. And then f prime of a is your slope of your tangent line or your derivative. So f prime of negative 5 is 8. So basically you get the exact same thing. It's just instead of calling it x1, y1, and m, they called it a value, f of that value, and then f prime of that value. Okay? And the whole reasoning behind that is because then they don't have to give you an equation, right? They can just tell you particular values to be using. Now, the important part about this is we found the equation of the tangent line, but they want to know now what is the approximation for f of negative 5.1 using this equation. So basically they're saying, I want to figure out what f of x is if your x value is now negative 5.1. Because I found the equation of a tangent line, which means that this would be a very close approximation to your actual graph at values that are very close to 5, or negative 5, excuse me. And so when we use this equation of the tangent line, we're actually getting a really close approximation to what our actual graph would produce, right? So if I have my slope, here's 5, oops, negative 5. Here's my equation of the tangent line. So even if I use negative 5.1 on my tangent line, that's still really close to what my actual graph might produce. And it's awesome. So let's do that. So let's go ahead and we'll plug in negative 5.1. So we get 8. So negative 5.1 plus 5 would be negative 0.1. And then if I do that times 8, I would get f of x minus 4 equals negative, 0.8, but then I'd add 4 to both sides. So I'd get f of x equal to, what's that, 3.2, I believe? And so then that's a pretty close approximation to what my graph would give me, my actual graph would give me at -5 by using the equation of the tangent line. Awesome. If it makes you feel better to just like rewrite these terms as like this is y1 and then this is m, we could do that as well. Let's try that on another problem. So in this problem, colors happening. So they said let f be a differentiable function such that f of -5 equals 7, f prime of -5 equals 6, and they want to know what's the approximation for f of -4.85 found by using the line tangent to the graph of f at x equals -5. So let's go ahead and we'll still identify our x1 is -5. y1 would be your actual function at -5, so that would be 7, and then your m would be your derivative at -5, so that would be 6. So now I can still go in and I can plug in all those pieces. So y minus y1 equals mx minus x1. All right, there's my equation. And so then now they want us to go ahead and plug in -4.5 and actually use this equation to solve for what your graph would get very close to giving you. So 6 -4.85 plus 5. Oh goodness, I might have to get out my calculator for this one. So if I get y minus 7 equals 6, -4.85 plus 5 would give me -0.15, I believe. And then if I do that number times 6, I would get y minus 7 equals -0.9. Let's say 6 times 0.15. Yep. And then I add 7 to both sides. So y would equal 6.1, approximately. No, what did I do wrong? Hold on. 5 minus 4.85. So this is -0.15, right? Yeah, okay. And then times 6 be -0.9 plus 7. I'm getting 6.1 a second time. Let's go back and double check everything. So x sub 1 equals -5, y sub 1 equals 7, m equals 6, y minus y1 equals 6, x minus x1. So it's x plus 5 for sure. Well, then what the heck? Oh, this isn't a -0.15. This is positive. I'm a fool. So then this would be positive, which means this would be 7.9. You guys, you're supposed to catch that. Oh man, that's okay. See, I was in the calculus, just the arithmetic. Always gets you. So don't feel bad if you get things wrong. I do it all the time, obviously. Let me know if you guys have any questions, but other than that, those are how these problems work. And obviously, like I said, they can kind of give you a guide for them, even if you get them wrong, right? Just follow the steps afterwards, like I did. I was like, what the heck did I do wrong? And I went and checked it all out. Turns out, 0.15 is what you get when you do a -4.85 plus 5. Oh, goodness. It's already been a long week, and it's not even Monday yet. All right, thanks, guys.